Greetings, Earthlings. Well, I've made first pass on repairs on the Keithley 171. These are the parts that I've replaced so far. These capacitors are out of the power supply, a couple of resistors, well, 3 resistors. These 2 resistors here are from the power supply, and they set the current limiting. And they've both drifted high, so I think part of what we were seeing with the minus 15 volt supply being, at minus 12 volts with all the cards plugged in, and then maybe minus 14 with most of the cards removed, could be a current limiting situation. As far as these capacitors go, this one measured bad, and that's in the plus 5 supply. The others measured okay. So, in theory, didn't need to be replaced, but, as long as I'm in there and they're 50 years old, except maybe this one, which is a little newer, makes sense to me to go ahead and replace them. And then there's this capacitor, which was on this board right here. And so that's, let me find the schematic. That's in the integrator. And that's actually the integrator capacitor. I'll put it up on the screen. Originally a 0.1 replaced with a 0.22. That's got to affect the calibration. So I don't know why that was done. Those are reliable. I mean, it's a capacitor. It's not electrolytic. It should be polypropylene. So I don't know why it was replaced, because polypropylenes are plenty reliable. Maybe it was a situation where, the guy couldn't get it into calibration, and so he thought if all the numbers were reading too high, if he put a bigger capacitor in there, that would bring the counts down and he could get it to calibrate. I don't know. I'm putting it back to normal. We're going to get this thing back to factory specs. So, here it is. Get that lined up there. And here are the new capacitors. They're all blue. They're all the same type of capacitor, same series. I used Nichicons, and they're high reliability, long life, high temperature. They're actually rated, spec'd as like automotive parts, so they're rated at 125 degrees C. So they should last for the rest of my life anyway. After that, I don't care. Someone else will get this. Here are the resistors, current limiting resistors. Not current limiting, but, they set the current limit on the 723s. So we can plug this thing in and have a look now at the voltages that we've got. I'm going to leave it tilted up. We'll have a look at the voltages, the power supply voltages, and see what we've got. So we're using the Keithley to fix the Keithley. Power is now on. Let's look at plus 5. I believe that's down here. 4.989. Yeah. That's pretty close. I would like to see it higher because there's going to be, that's measured right at the voltage regulator, so there's going to be some loss as it travels through the circuits and stuff. So I'd actually like to see it a little above 5, but still, you know, the spec is plus or minus 5%, I think, so we're fine. I'm just being anal here. Find the plus 12 and the or plus or minus 15. Where's plus 15? That's ground. Here's plus 15 right here. And I'd call that spot on. And let's look at minus 15 now. That's over here. Minus 15. Okay. That's now pretty darn close. So that tells me that the power supply is basically operational again. One thing we can look at is if I look at the voltage across this resistor here, that'll determine how much current it's drawing. So those are 5.6 ohms. And oh, something else I don't understand, and again I'll put this up on the screen. The power supply circuit, these transistors, so they've got the current limiting is 5.6 ohms, and it's however much current across, you know, through that resistor generates something like 0.6 volts. Will then put it into current limiting. So they're setting it to like 100 milliamps or just over 100 milliamps. Why do they need these big honking transistors that can, pass at least 3 or 4 amps? The 723 chips themselves can output 150 milliamps. So I'm not sure why the bean counters didn't make them take those out. But let's have a look. Can you see this? Okay. I'm going to try and do this. Voltage. I'll measure the voltage across that resistor. And yeah, 0.55 volts. So that's very close to current limiting. You know, it's drawing about 100 milliamps. So where's that going? Because most of the cards are unplugged. Well, as I pointed out last time, it's going to be in here, in this card, which I didn't remove, and I'm reluctant to remove it unless I have to, because it is the switch here, the range switch, is soldered directly to that board, and so they have to come out together. It's got this coupling here, which makes it a little easier to take it apart. The switch won't have to come off the front, but still, I'd rather not have to mess with it if I don't have to, but it looks like I may have to. Now, this has, so that board, that's the, they call it the switchboard. It's got the AC converter on it, AC voltage divider, and the range selection. Range selection is all passive, but the AC converter, I said the AC converter has an op amp. There, okay. Here's the AC converter. So we've got the minus 15 coming in here. It goes through a 10 ohm resistor, okay, which means that if I measure across that 10 ohm resistor, I can see how much current this card is drawing. Then it goes AC converter bias adjust. It goes to an op amp, and it goes out here to H. So again, there's a resistor. I can measure across that, see how much current is flowing here. The likely, well, there's an op amp there, and then the other circuit is here. This is the AC voltage divider. It also has an op amp there. It says H coming in here. That's the minus 15. So the likely situation, and that's the only place the minus 15 is used on this board. Okay, so I'm thinking likely situation is that one of those op amps is causing the problem, although it could be in here as well. But just to verify, get these back, just to verify, and you still see that, yeah. So I think I turned it. I'm gonna. This is still powered on. I'm gonna tilt it down. So that I can get at it here. And again, this is a 10 ohm resistor. And I did measure the resistance itself, and it's measuring, I think, about 11 ohms, so I really probably ought to replace it. It's a carbon composition. Okay, 1.2 volts. So that's drawing, about 100 milliamps just by itself. Okay, going back over to here. Yeah, that's on the current limiting guy. So the specs on these, this one here, and I don't know if you can see it, but there's the one here, which was this resistor, draws 10 milliamps at idle. This one should draw about 3 at idle. And I could find that 1K resistor. I think it's right there, and I could measure that. But what I'm going to do first, remember I did the touchy-feely test on the transistors and noticed some heat coming off of the one. I can't get my fingers on those op amps. But I have this. Okay. Thermocouple temperature module. So I'm going to set that to measure degrees Celsius. We'll plug that in here. Oh yeah, we're back on there. And that'll be on the 200 millivolt scale, and it should read, if you can still see that, yeah. It should read 1 millivolt per degree C. So ambient temperature, it says, is about 22. That sounds about right. It says 24 up there. So I'm going to touch this to this one. And yeah, 25. There's some heat in that. 26. Okay. And I'll try the other one, which is right here. And I think we found the problem. So it's, oh boy. Keep going. Let's see how I can go. It's going to be either the op amp itself is bad, or what it's driving. Oh man, 80 degrees. It's like the output could be short-circuited or something. But it really doesn't look like there's any path that would go sort of directly to ground. Well, it could be going through, these could all be set wrong, okay? And they could all be set at 0, and so the output is shorted. That's one possibility if someone's mucked with those resistors. 608, 609, 610. 90 degrees. And I guess then in that case the range, changing the range wouldn't affect it if those are the problem. So I'm going to switch off. And now the thing is, and I don't expect you to be able to see this, but that chip is socketed. It's an LM301A, and it is socketed. So it should be easy to replace. And in theory, I could replace it without removing the board. But at this point, I'm thinking I probably want to remove the board and check all those carbon resistors. But what I can do, if I can find R608, going back to this, R608, 609, 610. Yeah, that's these three right here. Okay. Just trying to see if they feel warm. Because if they're cranked down to 0, they might, well, at least the one that's selected by the range selector might feel hot. What I can do, put this away. The output is pin 6. Let's see if I can maybe get in there, measure the resistance. From pin 6 to ground. Let's use the Keithley. Because, all right, I'm going to switch off, and I'm going to unplug. Okay. I'm going to get these things out of the way. That should be pin 6 right there. Okay. 4.7K. Okay. So it does not appear that someone has been screwing with those potentiometers, calibration controls. So that leads me to believe that the problem is with the chip itself. LM301A, I don't have one handy. I could try, since it's socketed, I could try pulling it out. And I could put a 741 in there or an NE5534 just to see what happens. But otherwise, I need to order some parts.